In this brief video, I will show you how to simulate a closed loop system using MATLAB Simulink. First step is to open MATLAB and go to your working directory. Now, if you don't know what a working directory is and why it is important in MATLAB, you can always refer my previous video on an introduction to MATLAB for signal processing and control systems. I will link that video as well. Just a brief recap. If you can see this button, it says browse for folder. So when you click that, you can actually browse for a folder that you can set as a working directory for the MATLAB session. Now here I have created a new folder saying MATLAB in my desktop, so I will select that as my working directory. After selecting that, you can go to this current folder tab and then you can right click, and under new, since we are dealing with a Simulink model now, you can select model and it will take 2 seconds to open, and then you can name it whatever you want. So I will name it as transfer function. Again, one important thing to remember is when you are naming files in MATLAB, you can't use spaces. You always have to substitute spaces using underscores. After renaming that, you can double click or hit enter after selecting the transfer underscore function .slx files. Now all the Simulink files will be in the format of .slx. So you can open that and then a new window will open. So this is the Simulink window. Now as you can see, this is a blank white screen. So this is a blank canvas where we can actually build our closed loop system. In this video, for this purpose, I will be simulating this transfer function. Now this is a transfer function for a spring mass damper system. So I will be simulating the closed loop system for a spring mass damper system using a step input. And this is very basic level simulations. Now I have the transfer function with all the values here. I believe you have a prerequisite understanding about a closed loop system and its positions of the block diagram and various elements. So I will not cover those in this video. But for a closed loop system, we need some form of an input. So we need in this case, we are looking at a step input. Then you need to have the system, the transfer function, and you can have a controller, but in this case we are not talking about the controller. Then you need to have some sort of a feedback mechanism, and you need to have a comparator to compare the input and the measured value. To insert all those blocks, you have to go to something called the library browser. So when you click that, a new panel will open to the left hand side of your screen. Depending on the version of the MATLAB you are in, this will look a little bit different, because older versions you will get a new window, and then that window will have different icons for different categories. So this is the newest version, so that is why you have a new pane on the left hand side. Whatever you get, there will be a search button on top, right? Like this. In here I have the search button, so you can search. Now first I will insert my input. In this case I'm inserting a step input, so you can type step and you can press enter twice, and then you can find this icon. It's called step. There are some other icons as well, but this exact icon. Then to insert this icon to the canvas, that is to your right hand side, you can drag this and drop it. So this is our first block. Then the next element is the comparator or the summation block in the closed loop control system. So again you can search saying sum, press enter twice and take in this block. So this is the summation block. After that I have the system, which is the transfer function in this case. So in this instance my system will be the transfer function. So I will search for transfer and I will select the first one, not the discrete transfer function. Since here I'm doing a basic level simulation in continuous time, I will select the first transfer function block, which is in terms of S. and I need some way to observe this output. And the way to observe outputs is using some form of displays in Simulink. And here, since I need a graphical output, I will select a scope. So you can search for scope and you can drag it and drop it here. So this is the basic transfer function layout done. So I need to insert my values to this transfer function. Now if I double click on the transfer function, I can enter my coefficients to the numerator as well as to the denominator. Now notice the coefficients are between square brackets, so you don't delete those square brackets. It is important. Now my numerator is 1 over 4. So here I will just say 1 over 4. So that is my numerator coefficient. And in denominator, according to my transfer function, I have s squared. So the coefficient of s squared is 1. Then I have 7 over 4s. So again the coefficient is 7 over 4. Then space. Always you should separate the coefficient using spaces. And then my last coefficient is 12 over 4. And that's it. This is my transfer function done. Click apply and OK. Now you can actually drag it from the corners until you can see your transfer function. So it's not necessary to do this, but you can do it. Then I will connect all these points together. If you go near one block, you can drag and drop the arrow to connect them together. So I can drag and drop like this. So this is the forward phase. Now I will have the feedback coming from the output like this. And this is my basic level transfer function. Now I will close this library browser here. Now this is where the change should be, because we are simulating a negative feedback system, not a positive feedback system. That means here the below sign should be negative. So double click that and a new window will appear, and here you can select minus, and if you hit apply OK, then it will be minus. And this is it. This is your block diagram for the closed loop control system of a spring mass damper system for a step input. So this is the step input. Now on the simulation tab on top, you can click the simulation tab, and here you will see a simulate category. Inside the simulate category, you have something called the stop time. Stop time means the duration of a simulation. Now it is set for 10 seconds. That means once you run the simulation will run for 10 seconds and it will stop. And in this case 10 seconds is perfectly fine, but there may be other simulations where you need more time for the simulation. And then you will see a play button called run. This will essentially run your simulation and generate the output at the scope. So now I will click run. You will be able to see a brief progress bar on the bottom right hand corner. This is to indicate the simulation progress. Now it is done. This is actually a basic level simulation. Then you can double click on the scope and you will see the output. And this is the output of your spring mass damper transfer function for a step input in a closed loop configuration. Now there are a couple of things you can do here. Now first of all, if you see in the x-axis, your simulation or the response or the step input actually starts at 1 second instead of 0 seconds. So if I want it to start at 0 seconds, you can basically double click on the step block diagram, and the step time you can change it to 0. It was 1 earlier, you can change it to 0. And when you run the simulation again and observe the scope, now your step input has applied at t equals 0. I will expand this, and this is your output. Now a couple of things to remember here. First of all, if you don't like this background where you have a black canvas and then a white line, a yellow line, you can actually change it from view style. So you can go to view and style, you can change it. So suppose I want all white background and a black color line, so I can change the figure color to white and axis colors to white, and the axis labels is this one. I will select black as my axis labels, and then I will increase my line width from here for like 4, and then I will change the color of my line to black. So these are all settings you can play around with until you get your desired style. I can click apply and OK. Now this canvas has changed white and I have my output in black color. Suppose you want to measure something. Now, always when analyzing second order control systems, you need to measure the uh, settling time, rise time, time to first peak, and etc. So, unlike in MATLAB script, where you can basically simulate the step response and then you can automatically get the values for the system characteristics, here you have to do it in a semi-manual way. So, basically, you need to go to tools, go to measurements, and then go to cursor measurements. Then you will get two cursors. If you see here, you will have something called 1 and 2. So these are two different cursors that you can drag around with. So now manually you can just drag to this point because this is my peak point. Alright, so now I can see, okay, this is my peak point, and on the right hand side I will have another window telling what are those values. So this is the time for first cursor, this is the time or x-axis, and this is the y-axis. So that is how you can interpret it. So this means my first cursor is at the peak value. So time to first peak is approximately 1.98 seconds, and my peak value is 9.028 into 10 to the power minus 2. And similarly, you can do the same thing for the second cursor as well. Now, suppose you want to, let's say, measure the rise time. Right, rise time is the time taken for the signal to reach 63% of its output. So I have not calculated what is 63%, but I can roughly say, okay, from this point I will place one cursor, and at this point I will place the other cursor. Now my two cursors are between 0 and 63%, assume that. And now you can see on the bottom delta t and delta y. So this is a difference. So delta t means, okay, now I can finally figure out the time. So the time is at 1.00 seconds. That is the difference between the two cursors I placed. And you can also get delta y. So you can play around with this however you want, and you can actually, in a semi-automatic way, you can compute your system characteristic values with the help of the cursor measurements. Now, if you don't want the cursor measurements, you can simply click the close window and it will disappear. And if you want to, for example, take a screenshot for your documentation purposes, tip that I can give is to actually minimize this window and just reduce the size a bit, and then take a screenshot using like this snipping tool or Windows screenshot manager, because when it is at this maximized view, when you take a screenshot and put it to the documentation, it will be very first of all, the quality will not be that great, and second of all, these axis labels on the x and y axis will be difficult to read, and that's why if you have it in this orientation, it will have a reasonably good quality and you can read the axis values very easily. Now, there are other methods of actually saving the Simulink figure in a more high resolution PNG form or SVG or even PDF form that I will cover in later videos. So this is it for simulating the step response of a second order spring mass damper system using MATLAB Simulink.